Alright, next one here coming up, got another parallelogram. This one is a little bit tricky here, so you would set your two opposite sides equal, but unfortunately you have mixed variables right here. There's not really a way around this. It's not like a square or rhombus where you can set other sides equal. We're kind of stuck with this here. So we're going to have to use a system of equations, and we're going to have to solve with substitution or elimination. Okay, so we need two equations for this, so this would be our first equation. The second equation I would just call x equals 5y. All right, now since x is already solved for, we can actually go ahead and take this 5y and substitute it in to x in the other equation since x equals 5y. And when we do this here, that would be 3y plus 8, and then equals 2 parentheses 5y, and then minus 6. Okay, and then afterwards, then we can go and multiply those. That would be 10y minus 6. And then we can go subtract 3y from both sides, getting us 7y. And then we can go add the 6, which would get us 14. And then therefore, after dividing, you get y equals 2. Okay. So once you get that y right there, then you can go plug y back into one of the two equations. And in my opinion, the second equation is much easier to do. So then we can go and say x is 5 times the y that we just got, which was 2. So x is therefore 10. Right there. Let me double check that. Yep, x is 10 and y is 2 right there. So that's perfect. So sometimes we'll see those. I think we have a couple more coming up here towards the bottom or maybe even the next page. So we'll get back to substitution and elimination. Let's look at this shape here. This is a rhombus right here. So I think they wanted us to label it here. I don't know why certain ones have labels and not, but that's okay. A rhombus. Couple things you need to remember with rhombuses here. The very first thing that I mark on a rhombus is the diagonals are perpendicular. Let's write this. Let's say the diagonals are perpendicular. The diagonals are perpendicular. So you put a right angle right there in the middle. That means all four angles are right angles, which means, you can say that angle y right there should be 90 degrees. Okay, now another thing is the diagonals are angle bisectors. And here's what that means. That means this angle right here is getting cut in half by this diagonal. So if it's getting cut in half, that means both of those need to be the same. If you have 37 down there at that little angle on the bottom, then the one next to it should also be 37. And then because of your alternate interior angles, you can put a 37 degrees there and then a 37 degrees there because of two different pairs of alternate interior angles. Now the last thing we would want to do here is find this last angle here. So you do have a triangle, so you could say all of those angles add to 180. Since it's a right triangle, you could specifically do 90 minus 37. Because really you got 90 degrees right here of your 180, so that means this other two have to be 90 for the other 180 total degrees in the triangle. So just 90 minus 37 right there. Was that going to be 53, I believe, right there for Z? And then that gives us all of our angles, but if you wanted to go get your other angles, you could put 53 there, and then 53 right there because of the alternate interior. Now, the next thing they want us to do too, they do want us to find a couple of different side lengths. They want us to find MP and QN. So let's talk about that here. So MN is 10, and it's a rhombus, so all sides must be 10. Okay, and then on this here, you have, here, let me see, MP. Okay. Maybe those numbers are a little bit off there. I got to double check the key here. So now they want us to get MP. And what we're going to use here is the fact that we have a right triangle here. And I'm going to redraw that. I'm going to draw it separately here, just so I don't have as much going on with it. That's a right triangle. And since that's a right triangle there, and I didn't draw it perfect, let me see if I can get it a little bit better. Yeah, roughly that right there. That's a right triangle there. So I guess the big idea here is, since we know that the hypotenuse of that is 10, that should match up right there. We're going to go and find, I guess I'll call them maybe not x and y, maybe like a and b or something like that. We're going to use trigonometry to go find those distances there. So this one's a little bit advanced here, but we can use trig by just using O, A, and H. The trig function that uses O, and maybe I don't want a there, maybe I'll call it a C or something. The trig function that uses O and H is sine, right there. So we'll go sine of 37 degrees, and then equals the C over the 10, and then we would multiply both sides by 10. So that's 10 times sine of 37. And if you're typing this into the calculator, make sure that you put it in degree mode. Math. And then what we got here? So degree mode, you hit the mode button, and then you should make sure degree is highlighted. That's covered in the trig unit, so if you want to go and do that. And then sine of 37. And it's about 6. Yeah, about roughly 6 units right there, which is actually kind of interesting here. I kind of forgot that this was here. There's a 6 already right here. So really we just verify that that is also 6 right there. I guess everything kind of matches up there. And then so MP, when you double it there, should be the 12. Okay, but if you didn't have the 6, we would have to go and use the trigonometry to go get that. And then now that we have two sides of that triangle here, if you have 6 for this side right here, then we could go just use Pythagorean theorem there to go figure out what the B is right here. And I think there's a contradiction here. Maybe this QN. I need to double check that. I don't think that QN is correct here. Here's what I would do here after this. Well, once you get all that here, to go find QN, this entire diagonal, let's go ahead and use some trig again. Let's use a different trig function. Let's use the one with A and H. So that'd be the cosine function. And let's go of cosine 37 degrees and then equals 6, or I'm sorry, what did we start out with? 10. Oh yeah. Let's go B over 10, and then we'll cross multiply. That's 10 cosine of 37 degrees. All right, when we do that, that's about 7.9. That would round up to roughly about 8. Okay, so then we can go put an 8 right here, and then an 8 right there, and then double that. So I guess my key was actually wrong here. That should have been 16 when you double that. So I guess we'll get that fixed up there for you guys. So using trigonometry, you could, since they did give you the 6 originally, and then we had the 10, you could use Pythagorean theorem and also go and get the 8 as well. So that would be a second approach to that right there. So that one's pretty advanced right there. So there'd probably only be one of those, if any at all. But you know, good practice problem there. So all right, let's move along here. We have the rectangle here, so all the angles are there to the right. Let's talk about how to go get those angles. With a rectangle, here's what you need to go and mark here. The big property with the rectangles is that the diagonals are congruent. Whatever the diagonals are, the entire diagonal length, they're going to be congruent. And if those are congruent and they hold the property of bisecting each other from regular parallelograms, that means that all of these little pieces here are congruent. Now, if they're all congruent right here, think about this as an isosceles triangle. You have two congruent sides. All right? And what we know about isosceles triangles, we've learned this at one point, across from the congruent sides are congruent angles right there. So if I have a 22 degrees in that bottom left section of that triangle, then we'll have 22 degrees for that bottom right. Okay, and then you can go and use alternate interior angles from there. Okay, now from here there's actually two approaches you can do. Typically I'll use the fact that, hey, this is a rectangle and that's 90 degrees right there. So let's go 90 degrees minus 22 degrees right there to go get that leftover piece. And I believe that would be 68 degrees. And then you can do that at all the corners right there. Okay. And then two approaches you can go and do from here. You can go and use all the angles in that triangle, add up to 180. So let's go and do that there. Let's go 22 plus 22. which is obviously 44, and then 180 minus 44. And that's 136 degrees. If I did that correctly, let me check my arithmetic. Yep. And then vertical angles has another 136 there. And here's what I meant by two approaches. Here's where you actually have two approaches. To find angle 12 right here, you can either check and see if all those add up to 180. You can go and do 68 plus 68, subtract that from 180, and get your answer. Or you can use the fact that a linear pair needs to add to 180, which in my opinion is a little bit easier. So I'm just going to do 180 minus 136, and that should come out as, what is that, 50... that should come out actually as 44. So you can put a 44 there and a 44 there. To check this one, maybe just go check all the angles and see if those add to 180, and then you should be good to go. And that looks like I got those all right. By the way, it was a rectangle, so we can put that. I don't think this question comes up on the test, but they're asking how many triangles does the diagonals make. And of course, you got your 1, 2, 3, and 4 triangles. But if you wanted to get real fancy, you could say, well, hey, there's actually a triangle right there. So that's another. There's a triangle right there. That's another right there. Another triangle, and then another triangle. So I guess there's 8 triangles total. Not really necessary. I wouldn't worry too much there on that. Okay, moving along here. Let me delete that. Look at this right here. So you have a rhombus going on right here. I know it's a rhombus because it's perpendicular here in the middle, and the diagonals are bisected right there. So a rhombus more just for the fact that it's perpendicular in the middle. Now with rhombuses, don't forget all sides are congruent. So even though we don't have a side over here to set equal to x minus 2, all sides are equal. So I can set x minus 2 equal to any of these 3 sides. So what we're going to do is set it equal to the side that we actually have, just like this. And then you can subtract over x, and that gets you 5x, add the 37, and hang on, did I write that down right? Yeah, add the 37, oh yeah, I'm doing math in my head wrong. 35, and then divide, and x is 7. So that's what you'll do on the rhombus problems. Next we got a rectangle coming up here, and this one's a little bit tricky here because you don't actually look at it as a rectangle, you look at it as a right triangle right there. It's almost like you need to imagine that the rest of that's not there, the other stuff here. So the big idea with this is, it's a right triangle, so you can put a 90 degree right there and then say all 3 of those angles add to 90. Now another approach you could do is if this is 90 right here, then these two must also be 90. So you could do 3x minus 15 equals 90, or another way to solve it is 3x minus 15. Wait a minute, hang on, I didn't write that down right, hang on. It's not 3x minus 15, it's 90, it's 3x minus 15 plus 4x equals 90. Or you could do this, all 3 sides, or all 3 angles added together. 3x minus 15 plus 4x, and then plus 90 equals 180. Now, if you go and subtract 90 from both sides, you're going to get basically to that equation right there. So I'll go ahead and pick it up from right here. We can combine up those x's, that's 17x, or 7x minus 15 equals 90. We can add the 15 to the other side, that's 105. And then let me just use a calculator real quick here. 105 divided by 7 is 15. And that should work out right there. So be careful on that. Once again, I accidentally did 3x minus 15 equals 90. Initially, it's both angles added together equals 90. And that'll help you out on that. All right, next coming up here, we actually have, it appears to be a rhombus, but actually since the diagonals actually are all equal to each other, that means it's got some of the characteristics of a rectangle, and a rectangle and a rhombus combined together is actually a square. What does that tell us? That means all 4 corners must be right angles. And then also, if it's a rhombus, it's bisecting the angle. So if you're bisecting at 90 degrees, those angles right there are both 45. And actually, it's 45 at every corner, just like that. So the bisected angles all 45 degrees. And then we can use the fact, hey, if it's a rhombus, it must be a 90-degree angle right there in the middle. And that honestly gets you all of your angles right there. Really, with the squares, every time you get a square, the angles will all be the same because you're bisecting 90 degrees. They'll always be 45 degrees. So there's really not any variance to the angles here on these square problems right here. And then, of course, x here in the middle, it's a right angle, so x must be 90 degrees as well. And that's kind of the approach there.